In late 2025, scientists announced a discovery that surprised the entire scientific world. Deep under the ocean, about 4,000 meters below sea level, researchers found that oxygen is being produced without sunlight. This oxygen is now being called dark oxygen. Until now, scientists believed that oxygen on Earth could only be made through photosynthesis, a process that requires sunlight and living organisms like plants and algae. This new finding challenges one of the most basic ideas about life on Earth and forces scientists to rethink how life may have begun, not only on our planet, but possibly on other worlds too. This discovery was made in a remote part of the Pacific Ocean known as the Clarion Clipperton zone. The area is already famous because it contains trillions of strange, potato-sized rocks called polymetallic nodules. These rocks were once seen mainly as valuable mining resources. Now, scientists believe they may play a far greater role in Earth's history and future. The Clarion Clipperton zone, often shortened to CCZ, is a massive stretch of ocean floor located between Hawaii and Mexico in the Pacific Ocean. It covers an area of about 4.5 million square kilometers, making it larger than many countries. This region lies on an abyssal plain, which is one of the deepest and flattest parts of the ocean floor. For many years, the CCZ was thought to be mostly empty and lifeless. However, modern exploration has shown that it is actually home to a wide range of deep-sea creatures, including worms, sea cucumbers, microbes, and strange animals that exist nowhere else on Earth. Even though life here is slow-growing and fragile, it plays an important role in the ocean ecosystem. Scattered across the seafloor of the CCZ are polymetallic nodules. These are round, rock-like objects, about the size of a potato. They take millions of years to form, growing very slowly as metals in seawater stick to their surface layer by layer. These nodules are rich in metals such as manganese, nickel, cobalt, copper, and zinc. These metals are extremely important for modern technology. They are used in electric vehicle batteries, renewable energy systems, smartphones, and other electronics. Because of this, mining companies often call polymetallic nodules a battery in a rock. For a long time, scientists believed these nodules were chemically inactive, just rocks sitting on the ocean floor. The new research shows that this assumption was wrong. The biggest surprise came when scientists discovered that these nodules were producing oxygen in total darkness. At a depth of 4,000 meters, sunlight cannot reach. Photosynthesis is impossible. Yet oxygen levels in the water above the nodules were increasing instead of decreasing. This oxygen production was first noticed by accident. Sensors placed on the seafloor showed strange oxygen readings. At first, researchers assumed the sensors were broken. However, after years of repeated measurements, it became clear that the oxygen increase was real. This led scientists to name the phenomenon dark oxygen, meaning oxygen created without light. The study was led by Andrew Sweetman, a deep-sea ecologist from the Scottish Association for Marine Science. His team had been studying oxygen use in the deep ocean for more than 10 years. In 2013, Sweetman noticed something strange. Oxygen levels in some deep-sea locations were going up, not down. This made no sense because animals and microbes usually consume oxygen, especially in deep water where oxygen is limited. Years later, Sweetman and his team returned to the CCZ with better equipment and stronger experiments. They eventually confirmed that polymetallic nodules were the source of this unexpected oxygen. The key to this mystery lies in electricity. Scientists discovered that polymetallic nodules can act like natural batteries, or what Sweetman called a geo-battery. Each nodule contains different metals arranged unevenly. This creates tiny electrical charges on the surface of the rock. When these charges interact with seawater, they can cause a process similar to electrolysis. Electrolysis is when electricity splits water, HAO, into hydrogen and oxygen. In laboratory experiments, scientists measured a voltage of about 0.95 volts on the surface of the nodules. This is enough energy to break water molecules apart. As a result, oxygen is released directly into the surrounding water, even without sunlight or living organisms. To be sure that microbes were not producing the oxygen, the research team conducted a critical experiment. They recreated CCZ conditions in a laboratory and added mercury chloride, a chemical that kills bacteria and archaea. Even after all microorganisms were destroyed, oxygen levels kept rising. This proved that the oxygen was not biological in origin. It was being produced purely by chemical and electrical processes linked to the nodules themselves. This result shocked scientists because it showed that non-living objects could create oxygen in nature. For decades, scientists believed that oxygen first appeared on Earth because of photosynthetic organisms, such as ancient bacteria. This idea shaped everything we know about the origin of aerobic, oxygen-using life. The discovery of dark oxygen suggests that oxygen may have existed before photosynthesis became common. This means early life might have had access to oxygen much earlier than previously thought. If oxygen could form naturally in dark oceans, then life may not need sunlight to begin. This changes how scientists think about the earliest ecosystems on Earth. This discovery does not only affect Earth science, it also impacts space exploration. Scientists now wonder if dark oxygen could exist on other worlds with oceans beneath ice. Moons like Europa around Jupiter and Enceladus around Saturn are believed to have deep oceans under frozen surfaces. These environments are dark, cold, and under high pressure similar to Earth's abyssal plains. If oxygen can be produced without sunlight, then these alien oceans could potentially support oxygen-based life, increasing the chances that life exists elsewhere in our solar system. The findings were published in Nature Geoscience, one of the world's most respected scientific journals. This means the study was carefully reviewed by experts before publication. The scientific community has taken the discovery seriously, and many researchers are now working to confirm, expand, or challenge these findings through further studies. The discovery of dark oxygen has arrived at a very sensitive moment. Many companies want to mine polymetallic nodules to support green energy technologies. However, scientists and environmental groups warn that deep-sea mining could cause permanent damage. Mining would involve scraping the ocean floor, destroying habitats that took millions of years to form. It could also disrupt chemical processes like dark oxygen production that scientists are only beginning to understand. Deep-sea mining is regulated by the International Seabed Authority, ESA. This organization is responsible for protecting the ocean while managing mineral resources. Currently, 25 countries are asking for a moratorium or pause on deep-sea mining. They argue that humanity should not rush into mining before fully understanding the consequences. The discovery of dark oxygen strengthens their argument. It shows that the deep ocean still holds unknown processes that could be destroyed before they are even understood. Marine scientists not involved in the study have also spoken out. Lisa Levin from the Scripps Institution of Oceanography emphasized that the deep ocean is still a scientific frontier. She explained that producing oxygen at the seafloor is an ecosystem function, meaning it plays a role in supporting life. Removing the nodules could eliminate this function forever. Her warning highlights the danger of acting too quickly when science has not caught up. This discovery proves that the ocean is far more complex than we imagined. It reminds us that humans have explored less than 10% of the deep sea. What we once thought were simple rocks are now seen as active chemical systems. This forces scientists to rethink models of ocean chemistry, life evolution, and planetary science. It also shows that protecting nature is not just about saving animals, it is about preserving processes we may not yet understand. The discovery of dark oxygen carries a powerful message. It shows that nature still holds deep secrets, even on our own planet. It also warns us that exploiting resources without full knowledge can lead to irreversible loss. As the world searches for clean energy solutions, this discovery asks an important question. Can we move toward a green future without destroying the last untouched parts of Earth? Science does not yet have all the answers. But what is clear is that the deep ocean deserves patience, respect, and protection. The discovery of dark oxygen 4,000 meters below the sea is one of the most important scientific breakthroughs of our time. It challenges long-held beliefs about oxygen, life, and energy. It reshapes how we think about Earth's past and opens new possibilities for life beyond our planet. At the same time, it complicates deep-sea mining decisions by showing how little we truly understand the deep ocean. As history has shown again and again, when humans rush ahead of knowledge, the consequences can be severe. This discovery reminds us that science is not just about finding answers. It is about learning humility in the face of the unknown.